Um, this talk came from a Hack Miami local meeting where he volunteered to show us a little bit of the dangers of this type of technology, and we definitely thought that something was going on, and I thought it was important to create awareness on this type of dangers. So I invited him to create a talk for the conference. We obviously a lot of the know-how is going to be obfuscated because, like I said yesterday, I don't want people here walking out and redoing it. So you're not going to be able to do it. I hope so. But definitely, what we want is to create awareness. And we had recently a situation in Dallas, right, where the actual alarms went off, and there are several versions of what happened. One of them is that a tool similar to what you're about to see was used, right? An alarm might be a prank, right? But a bridge is not. A dam is not, right? It's basically the same technology. These things are available publicly, right? Cheap. It's almost like as you're about to see. Obviously, he does have an advanced knowledge of this type of technologies, but I based on what I saw, when you have people that are fanatics that want to basically harm us, all that drive may at times provide the patient and the trial and error enough to put two and two together. So in order to prevent that, it's better for us to create awareness and push for solutions and preventions and mitigations to this type of issues. So without further ado, I'm going to leave you with Mr. Will Nett. Please give it up for, and thank you. After this talk, we're going to have the final panel. I hope you had enjoyed the con. We had never stayed this late. Usually by 5, we're all gone. This year, as you can see, it was a conference full of talks. I hope you got your money's worth. There's still people playing CTF. There's still people doing log picking. There's people still in the villages. So I would like to thank you for really having so much energy, and this drive us to continue and give more back. So I will see you in probably around an hour for the closing panel, and please enjoy. I'll see you in a minute.
Thank you. Hi, everybody. So this talk is about aviation RF security. I'm not new to this with regard to, this is something actually has been out for a little while now. I think the first time I saw this was after I got this device and I started plugging around what I could do with it, experimenting with different RF technologies. And I discovered this, and I didn't actually discover it myself, but on my own personal discovery about an ADSB, and I pulled it up and I was like, whoa, this is bad. And how bad is it? And so I saw a presentation that was given by a guy named Modman, I think his name was, at DEF CON about 5 years ago. And while his talk was actually really good, he was very knowledgeable, and at least in the computer RF aspects of this, but he self-admittedly didn't have any sort of an aviation background. And so he didn't really understand the gravity of what he was actually throwing out there. Myself, I do have an aviation background. I started off in private aviation at the age of 14. I went into the United States Navy. I've worked on F-14 Tomcats, A-4s, and most recently, I used to be on an ISR platform, which is intelligence, surveillance, and reconnaissance. So I have been aircrew. I know a good fair amount about airplanes and their technologies and the equipment that they use on board and how they all work. So before radar, we've actually, this is from like World War I, late World War I, they would actually acoustically listen for airplanes. And it's these guys in the chairs here, and they would actually rotate this thing around. They're listening for airplane engines as they were possibly coming in the air, so they could warn the local base that you had something coming in. And this is pretty much sort of what modern radar looks like. And so in modern radar, basically the radar antenna sends out its ping and gets a reply back from the airplane as the signal bounces off the airplane, and that's what they call the radar signature. And with that radar signature, we can tell the distance, we can tell the speed of the aircraft based on the Doppler shift, and we can also, by nowadays, we can tell the altitude. The problem with modern day radar is it's not very accurate. It's actually off by a couple of number of feet that can actually cause serious problems. Because of that, usually when you'll hear when the ATC says they're stacking airplanes, they're actually keeping a fair good amount of distance between the airplanes. So typically, like in Iraq, our distance between us and any other airplane had to be a minimum of, I think, 500 feet. So radar, first discovered in 1886 by Heinrich Hertz. It wasn't very good in 1934, only worked roughly up to 3 kilometers. And back then, they could only detect direction. They didn't understand Doppler shift yet or anything like that, so they were actually pretty limited. By 1943, radar had most of the features you're familiar with, like speed, range, and altitude. The biggest modern faults are range and obstructions, curvature of the earth, buildings possibly in the way. Maybe one aircraft is too close to another aircraft and they can't quite see what's going on there. Or in some cases, there's just an object that's blocking. So in fact, because of that, during the 9/11 attacks, we lost track of several of those airplanes for up to 3 to 4 minutes because the airplanes were actually low enough in between buildings that the aviation radar could no longer track them. They had no idea what time they actually hit. So this brings me to another piece of equipment that's usually tied in with radar, and it's usually called your transponder radio. So the way a transponder radio works is before you take off and you're talking to air traffic control and you've filed your flight plan and everything, the air traffic control will assign you a code depending on what you're doing. So like if you're flying normal VFR or visual flight rules, just doing a puddle jump and maybe doing some training, they'll assign you code 1200. And there's a bunch of other special codes that are utilized within these transponder radios. And so typically every time you get pinged by the radar, not only are your transponder radio is replying back with this 4-digit code, and this helps air traffic control identify not just the blip that's on the screen, but who he is. So you see maybe those stacks that they have, that they line them up, and they'll have this transponder code. They know that it's a 747, American Airlines, flight number this, and they know where he's going in advance. And by using that, they can help direct traffic and make sure nobody's going to be bumping into each other. And this brings me another piece of equipment on board the airplanes that are currently being used. It's called TCAS, or Traffic Collision Avoidance System. Basically, it's a small radar typically found on airplanes, and my last airplane that we flew actually had one of these too. And this basically is to alert you that, hey, someone's getting really close within your airspace, and it actually does, like back in the day, used to call it like a bitch and Betty, and would alert you, warn you, and you could take evasive action. So TCAS nowadays is actually also tied in with ADS-B. So ADS-B utilizes GPS for much greater accuracy, and GPS is a lot better than radar. We know that it operates at 1090 megahertz. And so if you're looking at this image here, the way it actually works is almost like a mesh type of system. ADS-B can be broadcast from airplane to airplane, from ground to air, from air to air. So it's literally a mesh. And the way it works right now is the information that's being broadcast out is pretty much everything. Who I am. You can broadcast your transponder code, your altitude, your heading, your settings, your actual physical location, your airspeed, not already mentioned. So ADS-B stands for Automatic Dependent Surveillance Broadcast. It's a surveillance technology which in aircraft determines position via satellite navigation and periodically broadcasts it, enabling it to be tracked. The information can be received by traffic grounds control stations as a replacement for secondary radar. This is what the FAA wants to go away from radar into ADS-B. I read up on a lot of the directives that they're saying, and we pretty much are using a lot of ADS-B here in America as well as abroad. In Europe, I haven't looked too much in South America. I haven't dug up too much in that area yet, but I would not be surprised if you're seeing it there as well. The problem that we have, obviously, with ADS-B is two-factor. There is no authentication and there's no encryption. So these data streams are being broadcast out there. Anybody can see them. And of course, as you know, if I can see it, if I can hear it, I can probably reproduce it. So also on this, Flight Radar 24 is a website some people may have seen. And the difference between Flight Radar 24 and using your own ADSB is, so a lot of the websites that are out there that show you air traffic and where these planes are, by FAA regulations, they actually have to retard the stream randomly between 5 and 10 minutes. At least that was from the last document that I read. So what you're seeing, it gives you a general proximity on the website of where that airplane is, but let's be honest, 5 minutes, an airplane can travel quite a bit of distance. So it's great if you want to see if your grandma's airplane's about to land so you can head out to the airport. But if you really wanted to pinpoint where the airplane is, you need to do it yourself. So again, as we said, ADSB has no authentication, requires no certificates and credentials. Technically, it can be spoofed. Anybody who has a device, not like the one I'm using today. The device I'm using today is receive only, and as such, it's a relatively cheap device. But what's to say if someone had something else? So here's my receiver gig. And this is a screenshot from actually the last time we did the demonstration, which I can actually do right now. So the software, which I'll give you links to on the end of the presentation, the software is freely available. Anybody can download it. The link on here, the software is not there anymore, but if you go to that website, they refer you to the newest, latest updated software that actually works a little bit better, I think. And as you can see, we're already starting to show airplanes there. Just a moment. It took a little while the last time when I came in here to actually get more data. Boom, there we go. There's 2 or 3 airplanes. And so as I was saying earlier, if you look up on here, you can't see that part of the screen. You have to change size. There we go. So in this particular aircraft we're locking onto or watching right now, I don't see the name of it. The nation is USA. But as I was saying earlier, on the bottom there, you can see squawking code 2142. So that's what his transponder that he was designated by air traffic control, the number they gave him. So he's sending that information back. And of course we can see latitude, longitude, speed, 337 knots. And this is all real time. I'm not connected to Wi-Fi, and I'm not using any other equipment. And right now, I think I'm tracking, what, total of almost 20 airplanes? Any other interesting ones we got here? I had American Airlines a couple flights earlier on here. Anyways, getting back to the presentation itself. It's basically a world standard. So there's some interesting transponder codes that I found out there. And again, this is all information you can actually Google yourself. And again, if you know what you're looking for, so in this case, aviation transponder codes. Took me to a Wikipedia page, and I found out that there's certain organizations. This particular 2 call signs, Jenna and Jenna, are, as you can see in the bottom there, someone figured out it was actually the FBI. So it wasn't that hard to figure out. They were running their own ADSB, and they happened to notice that this one airplane, for some reason, and I'll show you in another slide, just kind of goes over a residential area and just keeps circling and circling and circling. And what would they be doing that for? So again, that's what it is. And apparently from what I got on the article that I got this image from, basically, down on the upper section in the area right there, the guy apparently had some kind of a grow farm that he was growing, and the down area there was the residential where he lived. And they tracked him driving out and checking up on his crops, and they waited till he got there and they busted him. So as I was saying, if you had a device that could transmit something like, say, a Hack RF1, again, if I can see it, if I can touch it, if I can hear, see it, I can reproduce it. Someone could very easily, and these data streams are not complex. This little device here with the simple code that is relatively, some amateur guy made himself, if he can actually get that and show you the information, it's not that hard to put the information right back out there. How to fix this? So there's a couple methods, and I don't want to just have someone playing 0 tuner in the background saying the world is falling. The government has known about this for quite some time, and it's been brought to their attention numerous times. Hey, this is really insecure, because if I can see it and I can reproduce it, that means I can put things in the air. And when I'm putting things in the air, that means other airplanes are also going to be reporting what they're seeing. And the airplanes actually have to take corrective action to whatever is potentially up there. If someone's actually broadcasting something like this out at, say, nighttime, where you can't have a visual verification if something is there or not, then by default, as my understanding protocol is, they have to at least be aware of the danger that something could be there and possibly take action. So in this case, this device is called a simple keyloader. You can't go buy one of these at Walmart. The device itself is not classified. The device's contents are classified. So what the device does is it stores crypto keys for airplanes. Some of you guys may have heard of things called Mode 4 or Mode 3. They also call it IFF, Identification Friend or Foe. And that's typically a key that's a crypto key. It's loaded into an airplane, and when out in like military organization areas, when they ping the aircraft and the aircraft responds back with the correct key, which changes every single day, then that airplane is authenticated, please don't shoot me down. Now, there's been a couple times, obviously, with ours that the code didn't work, or for some reason the radio didn't work, and people would just call in and get a waiver anyways. But if they had at least something like this, or some sort of a method of using a certificate of some way, authenticating them, if I'm not mistaken, most pilots these days, their actual ID card does contain a smart chip, or I know some of the airlines they do. They could easily put a certificate on that, somehow have that integrated with the aircraft's control system, so that these actual pings, these actual ADSB strings, when they're coming out, there is a way to authenticate and say, yes, this is an actual valid aircraft, or no, it's not. So this is the links to the actual software itself. And again, one of the things I was using for the skyvector.com, which you can actually see like a lot of the VFR charts and get some other further information off of that. There's lots of other projects out there for decoding ADSB. You can find Python scripts, so if you want to do your own GUI interface or something along those lines, those work as well. And this is actually gone really quick, I guess, because the first time I did it, and there was a lot of questions as well. It was a real big discussion group on this. NOTAMs is Notice to Airmen. So those are like bullet points that the FAA was pointing out to the pilots, hey, there'd be an air traffic advisory that there's construction going on over in this location, and be aware that there's poles being up and things of those nature. And again, there's the ADSB scope. Sure.
From a global perspective, if you came up with some kind of solution that can be deployed at ATC and then also easily installed in these various planes, how many years from, hey, here's the site that fixed this, to, hey, it's actually deployed in usable planes?
So the bigger problem with that is money. The government has spent a lot of money implementing ADSB, and like I said, it's here, it's in Europe, it's in Asia. They're using it pretty much everywhere. A lot of countries have made it a de facto standard that they have to be fully implemented. I think they had to be fully implemented by 2015.
That's what I mean. If you come up with something that interoperates, just like we were talking about the key
Sure.
If you had some kind of way that would allow easy integration into the existing ADSB stuff, but just kind of sign or encrypt the actual communications for the ATC.
So I did speak to a guy who called me up. I don't know who put me in touch with him, but he called my burner phone. I was like, yeah, okay, what do you want to talk about? And he claimed he was from the FAA. And he asked me very much the same thing, how can we do this? And I kind of gave him like the broad overview of, we need to integrate things like certificates. There has to be some form of authentication. And why some regular airplanes don't have this type of technology on there for authentication, I don't know. Military aircraft obviously have it.
Because of the mesh network style of aircraft to aircraft to aircraft to ground to aircraft to satellite, that's not how does another airplane authenticate another airplane and then share the secret without everybody knowing the secret?
You get airplanes with secret authority, of course.
Well, and essentially that's exactly what we had when over in Iraq with our ISR platform. That's why we had the simple key loader, which was it had to be stored in a safe. We brought it out once a month to take it over to the headquarters over on our base, and they would load the keys up. And I think everybody pretty much basically had the same key for that day. But, that's a device that's being locked up in a safe, and only a trusted person with an actual security clearance can take that device and go plug it into an airplane and upload. No. No, but they're... Well, they could very possibly have a parallel system. You know what I'm saying? It doesn't necessarily have to be military grade mode 3 or military grade mode 4, but anything is better than nothing.
Text with this. This is actually happening in the autonomous vehicles division now. So companies like Ford, Mercedes, BMW, they're working on a protocol called CAMP, and they are really talking about all these authentications from cars to cars, which will be on the road. So you just cannot. Only the car manufacturers, there will be a private certificate-based system. They are doing essentially the same things. FAA can do it for the aircraft as well.
Sure.
Again, if you switch over to military, that's kind of already being done. They are using professional vendors for doing that. So it's not totally impossible. To me, it's not clear. The threat vector is a little bit unclear here on, so yeah, you can put in the devices up there, and now what?
Now, okay, so hypothetically speaking, if you're putting devices up in the air and you're within a close enough distance from an actual air traffic control tower, they're going to see these devices. And their immediate reaction, especially if I'm running a passive system and I'm seeing airplanes and I start putting ghost airplanes up in real close proximity, they're going to start calling people to take evasive action. And if you are familiar very closely with some of these transponder codes, and I'm not going to tell you what some of these transponder codes are, but you can Wikipedia them, some of them will cause all kinds of havoc. So there are certain transponder, again, Wikipedia them yourself. It's not that hard to find. They're not classified by any step of the means. Sir? That's a good question. That I couldn't tell you. I mean, it's been... This vulnerability's been out for a while now. I don't think anybody's actually sat down with an HackRF1 and decided they were going to get violated by the FAA. I mean, I myself, sure, I think it'd be fun. It'd be great being able to just demo something like that, but, I enjoy freedom.
Relying on the satellite. I noticed in the diagram you had satellites in there.
Sure. So aligning up with as far as like the satellite connections, most of the airplanes, at least the ones that I flew in, you typically have an MRSAT connection. So they have that link to actually get to the satellites themselves. So they can broadcast their data through various different methods. They're broadcasting it out over the 1090 megahertz protocol, and they're also usually sending it out via MRSAT.
The system still works.
Sure. That was the whole idea of the mesh network idea between. That way the other airplanes could alert other airplanes, things like that.
I also learned up with regard to USR 320 at the SDR. The HackRF1 this pump is somewhat good, but that's more of a toy compared to
Sure.
those.
Right. Actually, a couple of weekends ago, they had the Ham Radio Fest over by Lauderhill, and I actually went over and spoke to a couple of those guys about, a little bit about ADSB, but not letting them know everything that we were talking about. And they pointed me over to a couple of other higher performance SDRs that actually do have transmit capability. And one of the ones he pointed me out actually had the ability of transmitting up to 20 watts. And so, yes, yeah, absolutely. And if you're broadcasting at 20 watts, you're definitely going to be seen by everybody within line of sight.
works for Velicom. There's even Android applications.
Yes, in fact, I actually was going to bring mine. I got like this, you've seen it now, it's a ridiculously large Android tablet. And I've actually plugged this into it, and Google Play Store has the application. You can plug it in there with an on-the-go cable, and it pulls it right up.
Yeah, I've been doing it. I live near airport now, and you can totally see like right on the flies.
Sure. And again, it's not going through a website that's retarded by 5 or 10 minutes. It's real time.
Copy control.
No, I mean, if you were transmitting, could you manipulate aircraft? I certainly would think if you put a ghost up there, relatively close proximity, he's going to probably more than likely take evasive action, just to, not by itself. I mean, that TCAS box is right in between both the pilots, at least it was on my last airplane, which was a Dash 8. And when that thing goes off, everybody in the cockpit can hear it, and usually the pick or the pilot in command is the one saying, I'm out of here, we'll divert and go around so we can figure out what the hell's going on.
The TCAS bosses talk to each other as well, and one would force up and one would force down.
Right.
So in this case, we know they're lost, so how would we respond?
That's a good question. I think that would be a few hair-raising moments of confusion for a pilot. He would probably just take whatever evasive action he could, just trying to gauge which direction it's coming from. Sure.
Press and laps around Fort Lauderdale Airport, and replay everything if you see with slightly different coordinates.
Oh yeah, if you had some, worse yet, if you had some kind of like you get like a Raspberry Pi, which is my thing, and you something like this transmitting out over a Hack RF1 or something better, put it inside an enclosure and just like, put it on top of one of those gourmet food trucks that drives around the airport all day long. Put 2 or 3 of them on there, and you'll see guys out there with Yagi antennas for days trying to find that damn thing.
So if you could spoof the codes, let's say, then you can also make it sound like an airplane setting out like an emergency signal?
Yes. Again, Google transponder codes or Google special aviation transponder codes. They're there.
The real question is, how does an airport react to every airplane in its vicinity reporting that it's been hijacked?
Right.
What is the playbook for that? Do you ground everything? Do you freak out? Do you
Do
start
this distraction
redirecting?
for another event that's going on?
Is one of them really hijacked and this is all big smoke screen?
Or something else that's going to happen?
I've heard instances in the past when I was much younger about people that were accidentally told to squawk and ident some of those codes, not realizing that it was a new air traffic controller and they were messing around with the guy. When basically they told him, go ahead and squawk that code, which basically said, I'm being hijacked. And of course, he didn't get jet scrambled, the last guy that I heard it happen to, but basically by the time he touched ground, there was like traffic all around him. I mean, he couldn't go anywhere. There was police, they had SWAT, they had everything, and the airplane was going absolutely nowhere. But again, that was 20 years ago. I'm not sure how accurate that story may have been.
So if you go and do this around Mar-a-Lago, you're going to have a bad time.
Well, and again, if you go to skyvector.com, you can see when he's going to be in town. So, you know when he's going to be there. Here you go. Good luck landing that helicopter.
Wouldn't if they thought ADSB was giving them false results, don't they have the overlay to the older system as well? And they could just fall back to it still?
That I haven't gotten a whole lot of information from the FAA with regard to. They are a little bit tight-lipped about this, obviously, for obvious reasons. But yeah, I've asked, so what happens when someone does put a ghost up in the air? What's your immediate reaction? They really basically told me they couldn't tell me. So as I only understand it from my aircrew experience, is that they have to treat it as if something actually is there, especially if they can't visually verify that they have to treat it as something that is possibly there. Because for all they know, the airplane's navigation lights aren't working and you can't see them, or again, it's nighttime and you just can't see anything at all. So.
If you were to jam this and make everyone blind, how do they operate?
I wouldn't. They would probably revert back to radar itself. I mean, I don't think it would be very feasible to try and jam unless you're jamming an airplane that's relatively close to you. Because again, the larger airplanes will. That's a big.
If we know that some VIP is flying in the saying it could affect delays, and there was some organized attack to jam that frequency within that general area.
Okay, so first off, if we're speaking of that specific guy, okay, a guy, bear in mind he travels with military airplanes, so they have their own. Okay, but yeah, he travels with military airplanes, and believe me, they've got a lot more sophisticated equipment. They know what seat he's in, for crying out loud. So.
Whoever that may be, not necessarily. It could be just a means and whatever mission somebody's trying to accomplish.
Sure.
Or let's say I'm going to be driving to my grow-op, and I know that there's a Cessna that always seems to follow me. I'd like to keep that Cessna on the ground.
If he's following you, he's following you. He's got VFR on you probably already, or for all you know, you may want to have your car taken a look at and see if you got any kind of little antennas on it broadcasting something. And I don't know what frequencies those operate at.
Dare I say, there was a similar incident already at an airport, back with GPS, where there was of all things, you said a Golden Gourmet or one of those food
Sure.
trucks. The guy wanted extra long brakes, so he had a GPS jammer, so his employer couldn't tell where he was.
Sure.
And he periodically turned on the GPS jammer on the grounds of the airport.
And that's not. In
It
fact,
took him at least
that-
a few months, I believe, to find it.
And that's, if I'm not mistaken, how Iran actually got one of our drones. They jammed the GPS on it.
So they claim that's how they got it.
Maybe they got our software. No, drones. No, oh, you're talking about military drones? Yes, a lot of the military drones that I've seen out there, they also squawk and ident their own codes, and that's for the comfort of the air traffic control. No, probably not the Stingrays. Things that travel significantly higher, can't go into the altitudes, but way, way high. High enough that you can't see them. This is, as far as I can tell, the ADSB it's continuously at a specific interval just putting these out there. And how they don't step on each other, I haven't even figured that out yet. So right now, yeah, I think the furthest I've actually gotten was standing in my house. I was able to track an airplane up to 300 miles away.
As far as having a device that can replay this information, how much information can you replay at the same time where and over a certain distance to the point where you end up creating a large number of ghosts in the air?
It's very feasible. And again, if you had the right equipment, and again, the Hack RF1 is it's a toy, and you're probably going to get just airplanes within close proximity. But if you had an actual ham radio that was digitally capable, and there's certain software out there, like I believe GNU Radio is one good one that actually has the ability of broadcasting if you're a ham radio enthusiast. And back in the day when those guys were doing things like packet radio, so something like on a device like that could feasibly do it. And of course, if you're a hammerhead and you've got a nice, good amplifier and a good tower antenna, yeah, you could broadcast a crap ton out there. And would it be advisable? No. I guarantee you, if you're broadcasting a strong enough signal, someone is immediately going to probably be zeroing in on your signal. And it's not that hard to triangulate at that frequency, I'm sure.
Software have like a packet capture where you actually see these packets coming and going?
Yes, actually, that would be the initial software here, this RTL 1090. So that is the software that's actually capturing the signal, decoding the packets, and it's rebroadcasting out locally on the network, or I can actually rebroadcast it out to another web server if I wanted to, join SkyVector and a few other places that are showing air traffic control. I could send my data to them, and then they would, again, retard the data 5 to 10 minutes, and then show it up on their website, so you could see approximately where the airplane is. But again, if you go back to the website, some of the websites on here, when I started digging into it and deeper, you can find Python scripts to do a lot of the stuff, automating things for you. So technically speaking, I don't think it would be that hard to actually start spoofing or putting stuff out there, or jamming probably wouldn't be very effective. Yeah, I mean, we were even actually able to secure shell to the port and IP address and see all the raw data as it was coming through as well. Any other questions? Well, this went on a little bit shorter than what I thought it was. I think it lasted a lot longer at the previous demonstration. So, but that's it.